Okay, this is part 2 for the circles unit review. So this is the back side of the review sheet. So 15, we're asking to find the arc length and sector areas for the highlighted regions of the circle below. So we are looking here at this highlighted arc. To find the arc length, the equation for our arc length. So we're going to just have been abbreviating arc length as AL. So our arc length is going to equal x over 360 times 2 pi r. So the x in our equation was the measure of the arc we're looking at. So the measure of the arc we're looking at is 300 because this 300 degrees here is a central angle. The measure of the intercepted arc is equal to the measure of the central angle. So this is 300. 300 divided by 360, that's going to be 5/6. Oops. 360, 5/6. Okay, and then 2 pi r, so our radius is 15, so 2 pi times 15. So that's going to be times 30 pi. Okay, so 30 pi represents the circumference of the whole circle. So this is 30 pi. Okay. But we don't want the circumference of the whole circle. We don't want the length of the whole circle. We only want length of 300 out of 360. So we only want 5/6 of the length of the circle. So we multiply the total length by 5/6. And again, we get that because we want 300 degrees out of 360 degrees. So that's going to be 150 pi divided by 6. You can just put that all in at once. And we don't really even need to write this step. We can use this step here. But 5 times 30 pi divided by 6. So 5 times 30 pi divided by 6 is going to give us 78.5. Okay. So our arc length here is 78.5. So around the whole thing here is 30 pi, which is about 93-ish, maybe 94. Okay. But we don't want the whole thing. We only want 5/6 of it. So we multiply by 5/6, and that's 78.5. To find the sector area, it's very, very similar. So we want the area under this arc. So we want this area here. Okay, so sector area is going to be the part of the circle we want, which is x over 360, times the area of the circle. So to find the whole area of the circle, that's pi times 15 squared. Okay. And again, the fraction of the circle we're looking at is 300 over 360. So we're looking at 5/6 of it. So if we multiply that fraction, 300 over 360, which is 5/6, times the area, times the area of the whole thing, that's going to be the area of the part. So again, I'm just going to move this. I didn't plan that out very well. I usually plan my board space pretty well, but did not do it well there. I knew I was going to run out of room, and I did it anyways, I had no idea what I was thinking. 300 divided by 360 is 5/6. Okay. 15 squared is 225, so 225 pi. So the area of this circle is 225 pi. We don't want the area of the whole thing. We only want area of 300 out of 360 of it. So we only want the area of 5/6 of it. So 225 pi times 5 divided by 6 is 589. Okay. 0.0. Number 16. Oh, we got to do the next one. So next one, very similar. So we have, let's delete this. Okay, we'll do arc length here and the sector area on the other side. So we'll do arc length. So arc length here is x over 360 times 2 pi r. So we are looking not at the whole circle, but at 120 degrees of it. Central angle, so the measure of the arc is also 120. So we're looking at 120 degrees out of the 360 around the whole circle. So we're looking at 120 out of 360, which is 1/3. So we're only looking at the length of 1/3 of the circle. So 1/3 of the circumference. The circumference is 2 pi r, so that's 2 pi times 11, okay, which is 22 pi. So 22 pi is the circumference. It's the length around the entire circle. We don't want the length around the entire circle. We want the length of 1/3 of the circle. So that's 22 pi divided by 3. 23.0. And that's going to be inches. This one should have been inches as well. So sector area. So it means the area of a section. Okay, again, same thing. We don't want to area the whole thing. We only want a piece of it. So we're going to have the area of the whole thing, pi r squared, except we're going to multiply by the part we want, which is x over 360. So we want 120 out of 360. So we're going to want 1/3, the area of 1/3 of the circle. So pi r squared is pi times 11 squared, which is 121 pi. Okay, so that's 121 pi divided by 3. $126.7, and it's inches squared is the unit. Inches squared. It's area. Now down to 16. Okay, 16, we want to find the radius, the diameter, the area, the circumference, the measure of arc AB, the length of arc AB, and the area of the sector inside of ABC. Okay, underneath the arc AB. Start with the radius. Radius is 12. Diameter is twice the radius. So that's 2 times 12, which is 24. Okay. The area is equal to pi r squared. So that's going to be pi times the radius squared is 12 squared, which is going to be 144 pi. The circumference equals 2 pi r. So 2 pi times 12, which is 24 pi. And again, you can leave it as in terms of pi, or we can multiply that out. It'll be something like, I don't know, 440 and 75 maybe. Right, but it's probably better just to leave the pi in there. It's more accurate, right? Because pi is an irrational number. So if you're getting a decimal, you're by default rounding. So pi is more accurate. Leaving pi in there is more accurate. The measure of arc AB. So angle ACB here is 45 degrees. That is a central angle. It's a central angle because C is the vertex of the angle. It's also the center of the circle. So if the vertex is the center of the circle, it's a central angle. Right? Central angle, center. Center, central. So the measure of arc AB here is going to be 45 because the measure of a central angle is equal to the measure of the intercepted arc. So this is going to be 45 degrees. Find the length of arc AB. So to find the length of arc AB, we're going to have to take our angle measure to find what portion of the circle it is. So we have 45 degrees out of 360. So 45 degrees out of 360. Then we need to multiply by the entire circumference, which was 2 pi r. Okay, so again, the equation we're using here is arc length equals x over 360 times 2 pi r. Okay, so our measure of our arc is 45, and the radius is 12. Okay. Put that all together, so 45 over 360, that's really 1/8, but we can put this all in here. 45 times 2 times 12 times pi divided by 360. It's going to be 9.4. So the length of arc AB is 9.4. Okay, then the area, again, we're taking our equation for sector area, which is x over 360 times pi r squared. Okay, so again, our arc measure is 45. It's out of 360 degrees for the whole circle, so we're only looking at 45 out of 360 degrees of the circle, which is 1/8 of the circle. And we want to find the area. So the area of the entire circle is pi r squared. So pi times 12 squared. But we don't want the area of the whole circle. We only want the area of 45 degrees out of the total 360 degrees in the circle. So again, 12 squared is 144 times pi times 45 equals and divided by 360. That's going to be 56.5. That's our sector area. So again here, circumference of the whole thing is going to be 24 pi, but we don't want the circumference of the whole thing. We only want 45 degrees out of 360. So we only want 1/8 of the total circumference. Area of the whole thing is 144 pi, right? Just the pi r squared part. Pi r squared, 144 pi there. But we don't want the area of the whole thing. We only want an area of 1/8 of it. So we multiply by the fraction, 45 degrees out of 360 degrees. 17. Okay. No, I don't know. I went to delete the board from the Chromebook. Okay. 17. So given the measure of angle MOL, is 80 degrees. And the length of segment LN is 16. So here's segment LN. The length of that segment is 16. Okay. We should notice that LN is a diameter. It is a chord that goes to the center. It goes across the whole circle. It splits the circle in half. Okay, however you want to look at it, it is a diameter. So our diameter is 16. We know the radius is half of the diameter, so we know our radius in the circle is going to be 8. This is where the diameter is coming from. We know the radius is half the diameter, so we know our radius is going to be 8. Find the length of LO. Well, LO is a radius. Okay, it connects the center of the circle to a point on the circle. That is a radius. So this is going to be 8. Length of LO is 8 because it's a radius, and the radius is 8. The radius is 8 because the diameter is 16. The diameter is 16 because it tells us the length of segment LN is 16, and LN is a diameter. Length of MO. MO is also a radius. It connects the center point to a point on the circle. So the length of MO is also 8. Find the circumference of the circle. We know circumference equals 2 pi r. Okay, so that's 2 times pi times the radius, which is 8, which is going to be 16 pi. Area of the circle, again, is pi r squared. Okay. If anyone gets any of the area questions wrong, I'm going to be pretty upset because I'm just going to be upset. Radius is 8, so pi r, or pi times 8 squared, which is going to be 64 pi. Okay. measure of arc LM. So here we have a angle LOM is a central angle. Okay. So this is a central angle. The measure of the central angle is going to equal the measure of the intercepted arc. So arc LM is the intercepted arc. So arc LM is going to be 80 degrees. So this is 80 degrees. The measure of arc L, let's change the color a bit here. L to N through M, or L to M through N, L and M. So L and M. Okay. Well, a couple of different ways we can do it. The easiest way is we notice the entire circle is 360 degrees. So 360 minus 80 is going to be 280. So it's 280 degrees. The measure of arc LMN. Okay, well, let's go back to LNM. Okay. The other way we could have done it is we notice this is a semicircle, so this is 180. So 180 minus 80 is 100, so we know MN is 100. And then MN plus this semicircle, which is also 180, would be 180 plus 100, which is 280. So two ways to do that. If you want to find arc LMN, okay, LMN, that's going to be 180 degrees. So semicircle. Arc MN, we just mentioned. So this is 180. So it's LM plus MN. We know LM is 80. So 180 minus 80 is going to give us 100. So this piece here is 100. Right? 100 plus 80 is 180. So this is 100 degrees. Next question, we want the measure of angle LNM. So here is angle LNM. Okay, it's this angle right here. It's an inscribed angle. It's not a central angle. It's an inscribed angle. So we know the measure of an inscribed angle is half of the measure of the intercepted arc. So LM is our intercepted arc. We know the measure of arc LM is 80. So this is 80. Okay. The inscribed angle, measure of the inscribed angle is going to be half, right? The measure of the arc is double the measure of the inscribed angle. So this is going to be 40. Right? 40 degrees. Okay, now we're on to arc length. So right now we've been finding the measure of an angle. We found the measure of arcs. We found the area, the circumference, some of the lengths. We found the radius. Okay, now we want to find the length of the arc. So we found the measure for all four of these arcs. Now we want to find the measure, we found the measure for all four of these arcs. Now we want to find the length for all four of them. Okay. All right. So we want to use our formula for arc length. I'll put it right here. Right, is x over 360 times 2 pi r. We already found 2 pi r. 2 pi r was 16 pi. Okay. X is the angle measure. We have already found all the angle measures, so all we got to do is substitute them in and so find the length. So let's start with LM. We found that this was 80. Okay. So we're going to do 80 over 360 times 2 pi r, which is 2 pi times 8. Okay, we can put that all in the calculator. So 80 times 2 pi times 8 divided by 360. And I got 11.2. So the measure of arc LM is going to be 11.2. Okay. Length of LNM. So LNM is this one. Well, we know the measure of arc LNM was 280. Found it to be 280. So we're going to do 280 divided by 360 times 2 pi times 8. And we'll put that in the calculator. 280 times 2 pi times 8 divided by 360, 39.1. Okay, so we know the length of arc LNM is 39.1. Length of arc LMN was 180, so 180 over 360 times 2 pi times 8. Okay, we just put that in the calculator. 180 times 2 pi times 8 divided by 360 is going to be 25.1. So we know the length of LMN is 25.1. The length of MN we know is 100, so it's just going to be 100 divided by 360 times 2 pi times 8. We just put it in the calculator. 100 times 2 pi times 8 divided by 360. It's 13.96, so that's going to be 14.0. Okay, so the length of arc MN is 14.0. So the key here, I think, is you got to make sure on the test, if you're asked for the angle, the measure of the arc, you're solving for the measure of the arc. If you're asked for the length of the arc, you're solving for the length of the arc. So the measure of the arc is simply how much of the circle is it out of 360 degrees. A circle is 360 degrees around. How much of the arc is it out of 360? So LM was 80 degrees out of 360. LNM was 280 degrees out of 360. Arc LMN was 180 out of 360, and arc MN was 100 out of 360. Okay. Then here for the lengths, we're actually finding how long they are. So maybe this should have had units, right? So this is degrees, and this is where you would then have units. So say the radius should have been 8 inches, then this would be 11.2 inches long. The length of arc LNM would be 39.1 inches long, LMN 25.1 inches long, and MN 14 inches long. So this is the degrees out of 360. How much of the circle are we talking about? Are we talking about what percent or what fraction of the circle? This is actually how long it is if you were to measure it. Okay, if you had a meter stick and you could bend it like a circle, how long is it? Okay. Last question here is find the area of the shaded region. Okay, so again, our sector area, that's our sector area question. So sector area is x over 360 times pi r squared. So pi r squared represents the area of the whole circle. X over 360 represents the portion of the circle we're talking about. So the shaded region, the arc for the shaded region was 80 LM. We said it was 80 because we know the angle was 80, central angle. Okay. So we want the area of just the shaded region. The area of the whole thing is pi r squared. So the area of the whole thing is pi times 12 squared, which again we found to be 64 pi. Okay, and we want to multiply just the portion it is. It's 80 degrees out of 360. Okay. It's not the whole thing, it's only 80 degrees out of the 360 degrees. So we can put that in, that's 144. So 12 squared is 144. So we have 144 pi times 80, and then divide by 360, and the area is going to be 100.5 units squared. So that's 17. So it's got a little bit of everything. Okay, 17's got a little bit of everything, except for the equations for a circle, which we haven't talked about yet, which is going to be the next 4 problems. So this is a really good problem to look at. If you understand everything on this problem, you're doing pretty well. You have an inscribed angle, you got central angles, you got diameter, radius, you got area and circumference, arc measures, arc lengths, sector area. got most of it on. Okay. 18 and 19, they're giving us the equation. We got to find the center and the radius. And the next one, we got to graph it. So if I write the equation for a circle out, we know it's going to be x minus h squared plus y minus k squared equals r squared. So we can rewrite, we have x squared plus quantity y minus 3 squared equals 18. We can alter that. Okay? This is the same thing, not alter it, but it's the same thing as x minus 0 squared plus y minus 3 squared equals 18. So again, h is then 0. K is 3. So the center is HK, so its center is going to be 0, 3. Okay, again, just flip the sign. So 0, positive 3. Then the radius, so r squared is 18. Okay, so we take the square root of both sides, and r is going to be the square root of 18. Okay, that's fine if you want to put that. If you want to put the decimal, that's fine too. The best answer, okay, is to split it up into 9 times 2 and make it 3 square root of 2. Okay. For 19, if I write the equation again over here, remember this is going to be an x minus negative 1 squared because 2 negatives make it positive. Okay, and then y minus 2 squared equals 9. Okay, so if we look at our equation here, again, we can just flip the signs and do negative 1, positive 2. But it's more clear if we write it as x minus a negative 1. H is clearly a negative 1. K is clearly a positive 2. So our center is negative 1. We can just flip the signs though if we want. Negative 1, positive 2. And the radius is going to be the square root of r. 9 is r squared, right? So r squared equals 9. So if we want to find r, we take the square root and we get 3. R equals 3. Okay. So we go to our graph. We have center negative 1, positive 2. So our center is right here. We're going to put the dot right there. That's the center of our circle. We know the radius is 3. So we know if we go up 3 units, there's going to be a point on the circle. So if we go up 3 units, 1, 2, 3, there's a point on our circle. If we go down 3 units, we have another point on the circle. If we go right 3 from the center, 1, 2, 3, we have a point on the circle. If we go left, 1, 2, 3, we have another point on the circle. Okay, so we know those are the points on our circle, so then we can just connect them. We can just connect them. So negative 1, 2 is the center. We got that because we flipped the sign. So negative 1, positive 2 is the center. Radius is 3. So we can go up 3, down 3, left 3, and right 3. And those are all great because the circle is made up of an infinite amount of points, okay, that are all 3 units away from the center. And it would be hard to find any of them on a diagonal, okay, because they're not going to perfectly line up. But we know if we go straight up 3, there's a point on the circle. If we go straight down 3 from the center, there's a point on the circle. To the right 3 from the center, there's a point on the circle. To the left 3, there's a point on the circle. Then we can just draw in the rest. Okay. 20 and 21. I want to do 21 first, and then we'll do 20. So 21, we have center negative 11 and negative 8, and a radius of 4. Okay. So here's our equation. It was x minus h squared plus y minus k squared equals r squared. Okay. So h and k, right? So h is negative 11, k is negative 8. So all we got to do it, and we know r is 4. So all we got to do is substitute in these numbers. So x minus a negative 11 quantity squared plus y minus negative 8 quantity squared equals 4 squared. Okay, two negatives make a positive, so we have x plus 11 squared plus y plus 8 squared equals 16. Okay. So again, we could have, and this is then our equation for our circle. And again, we could have just flipped. I mean, it's good to do it this way because that way you conceptually understand what's going on. But you just flip the sign. So that becomes x plus 11, y plus 8 equals radius squared, 16. You don't have to do this step. You can just flip the sign, go to that step. Okay, 20, same thing. We want to find the equation for the circle. In order to find the equation, though, we're going to need to find the center and the radius. So the center of the circle is right here. So that's simply going to be 1, negative 4. So our center is simply 1, negative 4. And our radius is 1, 2, 3. And our radius is 3. Okay, we got the radius because we know that the circle is 3 units away from the center. We did that by going straight up. We could have gone straight down. That's 3 units away. The right is 3 units away. The left is 3 units away. Okay, the distance between the center and the circle is 3 units. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, if we could tilt the graph, it would be 1, 2, 3. So put in the equation, so we have x minus 1 squared plus y minus negative 4 squared equals 3 squared. All right, again, h equals 1, k equals negative 4. Again, you could skip this step if you wanted, x minus 1 squared. Negative and negative is a positive, so it's y plus 4 squared equals 9. Okay, and that's going to be our equation for this one. Right, hk is the center. So the center is hk. Then we got r. All right, so that's it for the material on the test. The last two are going to be the extra credit questions dealing with completing the square. So the last two here are our extra credit questions. So both of these are completing the square. Okay. So we want to find the center and the radius of each circle below by first completing the square. So we need to complete the square and then use the equation we find from completing the square to find the center and the radius. So want to reorder this. So let's do x squared plus 16x plus y squared minus 22y. And let's move the 20 to the other side. Let's add 20 to both sides. Okay, we're going to add 20 to both sides. Now we want to get perfect squares. Okay, so we want to leave a blank here. Plus y squared minus 22y plus leave a blank, and that's going to equal 20. So let's deal with the x's first. Okay, we want to make a perfect square. So again, how we do this is we have to take the b here, 16 divided by 2. 16 divided by 2 is 8. Then we want to square it. 8 squared is 64. Okay, if we add 64 to this side, we have to add 64 to the other side. Then we have y squared minus 22y. So 22 divided by 2 is 11. 11 squared is 121. So we can divide by 2 and then square it. 22 divided by 2 is 11. 11 squared is 121. Okay, we now have a perfect square. So this will factor to be x plus 4 squared. right? Because if we multiply it out, okay, it's going to be x squared plus 4x. Oh, I'm sorry, 8. Yeah, I don't know what I was thinking there. Okay, so it's x plus 8, x plus 8, right? Because it's what multiplies to get 64 and adds to get 16. The answer is going to be 8 and 8. 8 and 8 add to 16, they multiply to 64. So you get x plus 8, x plus 8, right? And again, that's going to be, if you FOIL that out, x squared plus 8x plus 8x plus 64, which is x squared plus 16x plus 64. Okay, so when we factor this, we get x plus 8 plus x plus 8. Okay, so it's x plus 8 squared. Okay, and then we add, again, this is going to be y minus 11 squared. Okay. Y minus 11 times y minus 11, if we factor that out or FOIL that out, is going to be y squared minus 22y plus 11. Again, we can think of it as what multiplies to get 121 and adds to get negative 22. Well, it's going to be negative 11 and negative 11. And the reason this works out is because that's how we designed it to work out, by dividing by 2 and squaring it. The 121 we added here, right, we should have added 121 to the other side. The 121 we added here, well, it was designed to make this negative 11 and negative 11. It was designed to make this one negative, or positive 8 and positive 8. Okay, that's why we're adding 64 and 121. Okay, so we have those two perfect squares. We've now factored them, and that's going to equal 20 plus 64 plus 121. So we had plus 20 because we moved 20 over. If we add 64 and 121 to this side, we have to add it to the other side of our equation as well to keep it balanced. So that's going to be 185, 195, 205, I believe. Okay. So 141 plus 64. Okay, the question asks to find the center and the radius. So the center of our circle is going to be negative 8, 11. Okay, got to flip the signs, and then our radius is the square root of 205. 64, let me just, because you'd think it would be like 225 or something, because that's a perfect square. 205. No, it's just 205. So radius is square root of 205. Okay. A perfect square. So these are perfect squares because when you multiply them together, like for example, 64 is a perfect square because 8 times 8, right? Square root gives you a whole number, right? This is a perfect square because square root of x plus 8 squared is x plus 8, right? X plus 8 times x plus 8 is x plus 8 squared. That's what makes it a perfect square. Okay, do 23 here. Okay, and then go home. Well, I got to make copies of the test and then go home. Okay, so we want to reorder this. So we want to move y squared and y to this side. And then move 84 to the other side. So we're going to end up with x squared minus 12x plus y squared minus 16y equals negative 84. Okay. And again, we want to leave some space. So net x squared minus 12x plus something plus y squared minus 16y plus something equals negative 84. Again, we're trying to find a number that's going to make this a perfect square. So we want to divide 12 by 2, that's 6, and then square it. 6 squared is 36. That way this becomes x minus 6 squared when we factor it. Again, the reason we're doing 36 is what adds to negative 12 and multiplies to 36 allows us to have these numbers be equal. And the way we do that is we divide this by 2 and square it. That gives us 36. So we have negative 6 and negative 6. Okay. That's the reason we're adding 36, is so we can get negative 6 and negative 6 here. So we can have x minus 6 squared. Perfect square. Square root of it is x minus 6. X minus 6 times x minus 6 is x minus 6 squared. Okay, here we want another perfect square, so we divide the 16 by 2. Again, if we were to put a chart here, we have negative 16. So if we divide by 2, we would get negative 8. Multiply, we get 64. So the reason we're adding 64 here is so we can have negative 8 and negative 8. So again, this is going to be y minus 8 squared. If we add 36 to this side, we have to add 36 to the other side. If we add 64 to the side, we have to add 64 to the other side. So negative 84 plus 36 plus 64, that's 100, so it's going to be 16. I was just about to say I'm being lazy and don't want to do it in my head, but it was that easy. Wasted battery on the calculator. So it's 16. So the question is, what is the center of the circle and what is the radius? So the center of the circle is 6, 8. The radius is going to be 4. Square root of 16 is 4. H is 6. K is 8. And that's part 2. So again, those two are extra credit. And again, there's really no such thing as extra credit. There's just points you can get. Calling it extra credit isn't really significant in any way.